Okay, we're going to go over the Chapter 2 review for the test, and we're just going to go in order. All right, number 1 says an object travels from rest, so remember that means that VI is 0. It accelerates uniformly down an incline. If the object reaches a speed of 40 meters per second, so VF is equal to 40, its average speed is. Now they give us all this information and they tell us t is equal to 5 seconds, but you don't need that because they ask for the average speed, and the average is just going to be 40 plus 0 divided by 2, which is 20. So the answer is choice C, 20 meters per second. Number 2. It says, what is the average velocity of a car that travels 30 kilometers due west in 0.5 hours? So again, the average velocity is going to be the displacement over the time, which is going to be 30 kilometers west divided by 0.5 hours. So the average velocity is 60 kilometers per hour west, which is choice D. Number 3, a race car traveling at 10 meters per second accelerates at a rate of 1.5 meters per second while traveling a distance of 600 meters. The final speed. So remember, you want to chunk this. So first it says that VI is equal to 10 meters per second. Then I have the acceleration is 1.5 meters per second squared, and x is equal to 600 meters, and I want to find VF. So now I'm going to say which equation has these 4 variables, VI, A, X, and VF. So I'm going to use the equation VF squared is equal to VI squared plus 2AX. And when I substitute that, I'll get choice D, which is 44 meters per second. Number 4, a boat initially traveling at 10 meters per second, so VI is 10, accelerates uniformly at a rate of 5 meters per second squared, so that's my acceleration, for 10 seconds. So t is equal to 10 seconds. How far does it go? So we want to find x. So I'm going to look for the equation that has all those variables, and that's going to be the equation x is equal to VIT plus 1/2 AT squared. And then I'm going to substitute in my values 10 meters per second times 10 seconds plus 1/2 of 5 meters per second squared times 10 seconds squared. And don't forget to carry your units through and cancel your work in order to check it. Okay, so the answer for number 4 comes out to be 350 meters. Number 5. Number 5 says an object has a constant acceleration of 2 meters per second squared. So we see that A is equal to 2 meters per second squared, VI is equal to 8, and we see that t is equal to 10 seconds. Oops, that was number 4. All right, so number 5, A is 2 meters per second, VI is 8, and then the other thing they gave us was VF was equal to 28. So they ask us, they want us to find the time. So now I'm looking for an equation that has A, VI, VF, and T. So that's the equation that VF is equal to VI plus AT. And then I substitute in my values in VF, and T comes out to be 10 seconds. Now you're going to rearrange this equation to solve for the unknown in terms of the known. So it's going to be VF minus VI over A is equal to T, and then substitute in my values. All right, number 6. Number 6 says, which is constant for a freely falling object, and that's the acceleration. Number 7, which graph best represents the relationship between mass and acceleration? Well, we see as the mass increases, it doesn't matter because the acceleration for something that is falling, the acceleration due to gravity is the same. It's 9.8, so the acceleration is going to be a straight line. All right, number 8. Number 8 says that a clam dropped by a seagull takes 3 seconds to hit the ground. What is the seagull's approximate height above the ground at the time the clam was dropped? So here, the key is that they tell us it takes 3 seconds is the time, and they want to know how high up he is. Now, for free fall, we know that g is equal to negative 9.8 meters per second squared, and when he drops the clam like this, we also know that the initial velocity is 0. So we want to find y. So now, what we're going to do is we're going to use the equation y is equal to VIT plus 1/2 gt squared. The initial velocity is 0, so it's just y is equal to 1/2 gt squared, and then we substitute in our values, which is 1/2 times negative 9.8 times 3 seconds squared. So y ends up being negative 44, and it's negative. Now here they don't ask you for the negative sign, but the negative means that you're measuring from here down. Okay. All right, number 9. Number 9 says a rock falls freely from rest near the surface of a planet where the acceleration due to gravity. So already I see for number 9 that g is equal to negative 4 meters per second squared. And it says, what is the speed of the rock after it falls 32 meters? So y is equal to negative 32 meters. I also know that vi is equal to 0 because it's falling. And it says the rock falls freely, so they drop it. So I'm going to use the equation vf squared is equal to vi squared plus 2gy. This is 0, so vf is equal to the square root of 2gy, and then I'm going to substitute in my values and solve. So it's going to be the square root of 2 times negative 4 times negative 32. And if you carry your units through and cancel them, it'll check your work. All right, so the answer to that one is 16. Number 10. An object is allowed to fall freely near the surface of a planet. So it falls 54 meters. So y is equal to negative 54 meters. T is equal to 3 seconds, and vi is equal to 0. So our equation is y is equal to VIYT plus 1/2 gt squared. This is 0, the initial velocity, so it just becomes y is 1/2 gt squared. And since I'm solving for g, I'm going to rearrange the equation and solve for this. So I'm going to multiply both sides by 2, and then I'm going to divide both sides by t squared, and that's equal to g. So it's 2 times negative 54 over the 3 seconds squared. Now g should come out to be negative because according to my sign convention, down is negative. All right, number 11, it says the graph below represents the motion of an object traveling in a straight line as a function of time. What is the average speed? So we have to do it in 2 parts. So I would first look at this and say, well, from 0 to 2, it's going to be 2 minus 0 over 2 minus 0. So 2 divided by 2 is 1. Okay, because remember, this is a distance versus time graph. On a distance versus time graph, the slope of the line is the speed. So here, the slope of that line is 1, and then from 2 to 4, the slope is 0. Now, I could calculate that, but I can see that that's 0, because the horizontal straight line is a 0 slope. And then to find the average, I say 1 plus 0 divided by 2 is 1/2, which is 0.5, which is answer C. Okay, now for number 12, it says base your answer to the following question on the 4 graphs below. And then it says what object traveled the greatest distance. So on a speed versus time graph, the area under the curve is the greatest distance. Now, the area under the curve, this is the curve. So this is a triangle, this is a rectangle, this is a rectangle plus a triangle, and then this is also a rectangle plus a triangle. Now, sometimes you can tell by looking at it. What I did was I calculated it. So this one, the triangle is 1/2 base times height. So it's 1/2 of 3 times 30. So this one, the area is 45. This one is 3 times 20, which is 60. This one is, I have to do this plus that. So I see already that this one is larger than that one. So this one, I already know that this is 60, and then I do this little triangle, which is 1/2 base times height. So it's 1/2 of 3 times 10 is 15. So this is 60, and this is 15. So the total is 75. And then the last one, I do the rectangle and the triangle. So it's 3 times 10. This is 30, and then I do 1/2 base times height, which is 1/2 of 3 times 20. So that's also 30, so this is 60. So the one that's the greatest is going to be this one, C. All right, the next page, we're going to look at the graphs. And the first one says, the graphs below show speed as a function of time for the 4 cars. Which car experienced the greatest average acceleration? Well, the first thing I'm going to do is look at the graph and say this is a speed versus time graph. On a speed versus time graph, the slope of the line is the acceleration. So the one with the steepest slope, that's going to be the one that's my answer. And I'm not going to calculate it. I can see that right here, that's the steepest slope. So that's why the answer is D. Number 14 says, which graph best represents the motion of an object whose speed is increasing? So the one whose speed is increasing, if I look at it, remember, a speed that's increasing, that means it's an acceleration. Well, and on distance versus time graph, this shows a constant velocity. So a constant velocity means that the acceleration is 0. So this one's not the answer. For part B, again, I have a straight line, so this one's not the answer. Now remember, if you knew right off the top, on a distance versus time graph, acceleration has to be curved. So it has to be one of these two. So this one wants to know which graph represents the motion of an object whose speed is increasing. So that means it's a positive acceleration. So this one is positive, and this one is decreasing. So this one is the answer. This is a negative acceleration, and this one's a positive. All right, for this graph, it says base your answers to the following questions on the graph below, which represents the relationship between speed and time for an object in motion along the straight line. So it says, what is the total distance traveled by the object during the first 3 seconds? So here's the first 3 seconds. Well, this is a speed versus time graph, and the distance is going to be the area under the curve. So I have 2 areas. I have this one, which is a triangle, and then I have this one, which is a rectangle. So the first one, I'm going to do the triangle plus rectangle. So it's going to be 1/2 base times height plus base times height. So for the triangle, it's going to be 1/2 of 1, this is 1, times 10, this is 10, plus the rectangle, which is, this is 2, and this is 10, so 2 times 10, so this is 5 plus 20, so it's 25, which is answer C. And for the last multiple choice for the test, again, whenever you see a graph on the test, you're going to ask yourself the first thing, is this a distance versus time graph or a speed versus time graph? So if it's distance or position versus time, we know that the slope is either going to be speed or velocity. If it's a velocity or speed versus time graph, the slope is acceleration. And then we also know on this type of graph, for velocity or speed versus time graph, that the area under the curve is going to be either distance or displacement. Okay. So now when I look at number 16, and it says, what is the distance covered? Okay, here's distance. That's right here. This has nothing to do with physics. All I'm doing is reading the graph. So now it says what distance is covered between 2 and 6. So here's 2. Here's 6. The difference is going to be 6 minus 2, so the answer is 4. So I didn't even need to be in physics to answer that question. All right, so this is the multiple choice. Now remember, the multiple choice is very similar to the test. If you don't just memorize these answers that I went over. What you need to do is actually do them yourself and check your answers and make sure that you understand this. And to do well on the test, you just look at the solutions on Edline to all the homeworks. You look at all your everything that we've done, besides the homework, this review sheet, the other review sheets. Look at all your answers on Edline and make sure you know how to do anything, and you'll do very well on the test. So studying really makes a difference. And on this test, you really have to also study all the equations. So make sure you write them all out like 10 times, and if you do that, you'll definitely get a good grade on the test.